So thank you everyone for coming and your interest in discovery within the IIIF and Europeana space. I'm Rob Saunderson, the co-chair of the IIIF Discovery TSG and Director for Cultural Heritage Metadata at Yale University. Previously I was at the Getty Museum in Los Angeles. We have three presentations, and I believe that Jeff is going to talk more about the format of the activities. So I'm going to focus on the ecosystem and sort of an overview of how we see everything fitting together, rather than the nuts and bolts and angle brackets and kilo brackets and so on. And here we go. So discovery today is not particularly discovery oriented. Instead, for IIIF, we have pre-configured viewers like Mirador and Universal Viewer. And you have to know where the manifest is, either you, the user, or you, the viewer, implementer. So then once you know the URI of the manifest, then it's easy. You can simply retrieve it and render the content. But that, of course, doesn't scale beyond a very short list of manifests. And we need to improve that. So that was sort of the initial impetus for the Discovery TSG. There are two main areas of work, and I'm going to focus on the first one, which is crawling and harvesting of IIIF resources in order to create a search engine that would then allow the discovery of those resources. So essentially, the question that we're trying to answer in this part of the work is, what is better than OAI PMH for the purposes of discovering IIIF resources? And I'm going to conclude with some thoughts about that question. The second area, which is we now call content state, is how to communicate those discovered resources from the search engine where you found them, or from the website, or from email even, to applications that would allow them to be viewed. So essentially the question here is, given an arbitrary search engine that searches IIIF resources, how can we use our preferred viewer, which could be completely custom and unknown to that search engine? We have a charter for the TSG, which you can go to that link in the community section of the IIIF website to look at the details of the chartered areas of work. Okay, but we're going to focus today on crawling and harvesting as probably the most interesting overlap with Europeana. So the first thing that we need to be able to do is to publish a set of changes that have been made to the content of the IIIF content. In order to do that, we have a construct which we borrow from the W3C Social Web Working Group called an activity stream. Activity streams are made up of pages, and each page has many activities. Those activities are, things have a manifest or a collection has been updated, it's been created, or it's been deleted. There's some additional activities such as it was moved or renamed, or it was added to a collection or removed from a collection. But essentially, we have a long list of things that have happened, and where those things are activities about IIIF manifests. So what we want to do is connect that manifest to the viewer user interface over there on the right-hand side of the diagram. So level 0 is basically just this same setup where there is a set of activities, they're about manifests. You can crawl that long list and find references to all of the manifests. So this is essentially just a sitemap of every single manifest that you know about, and really nothing more. It doesn't even have times of when things change. So level 1 then adds that critical piece of information. When did the activity take place? When was the manifest published, or when was it updated? At this point, we also introduce some additional restrictions, such as the set of activities across all of the pages within the collection has to be ordered from the least recent to the most recent activities. So the most recent thing to happen is the last entry in all of the pages, which means that, which we'll get to in a second, crawlers can use that in order to find things, activities that they haven't already seen. Level 2 adds a type of activity. So at level 1, you don't even need to say that it was created or updated. You just say, here is when something happened to do with this manifest, and we don't necessarily even know what that was. It could be created, it could have been modified or deleted or anything else. At level 2, we know a little bit more. So we know that not only did it happen at this time, it was this sort of update. Let's say it was created. And we can also add additional properties such as who performed the activity, and which institution it was part of, and so forth. So this is the core of the Discovery API, which is now at 0.9 and very soon to go to 0.9.1 with a few minor changes that have come up since we published the first beta. Okay, so I said that we were going to talk about crawlers. So the crawler then, which is collecting up manifests with the intent to build a search engine over top of the content, first goes to the activity stream collection, which has a reference to each of the pages. To the first page and the last page. It then goes to the last page, because it can walk backwards through the list, to retrieve the set of activities. It starts with the last activity, checks to see that it hasn't already processed that activity, and if not, it retrieves the manifest. And then it can do what it wants with it, such as indexing the metadata and labels and so forth in that manifest into a search index to then display to a user at the end of the day. However, indexing manifests is not really the intent of what a manifest is. Manifests are from the IIIF Presentation API, where the data in the manifest is intended to be only enough to drive a viewer and not necessarily any semantic information that could drive search. So we have another property within the manifest and also potentially within the activity stream of see also that points from the manifest to a metadata document that describes the object that the manifest is a presentation of. So imagine that the manifest describes a photograph. The metadata could be in Lido or any other format describing what that object is. If it's a book, it could be in Mark or mods or anything else. Typically, we would also want to identify what that sort of metadata it is. So whether it's Lido or mods or Mark or CRM or anything else. And that's that profile parameter that we've added. So then the crawler instead should index the metadata because it will be able to process that much more effectively rather than the presentation intended strings in the manifest. We can then build a search user interface on top of those indexes. The user searches the indexes and can use a viewer to render it. How do we get there? This is the content state API, which is currently published at 0.2, although we're about to move to 0.3, that allows you to migrate or communicate from the blue search domain into a completely separate green viewer domain using a standard protocol, such that the viewer can then go and retrieve the manifest and render it to the user, and everyone is happy. So now we've completed our circle. But of course, how does the activity stream get found by the crawler in the first place? How does it know where to go? Haven't we just moved the problem from the crawler needing to know the manifests to the crawler needing to know the activity stream collection? And the answer, of course, is yes. So instead, what we're recommending is that there is a central IIIF registry of activity streams, which Glenn manages, which is just another activity stream collection of collections. So the crawler can start with that collection of collections, which is at a well-known URI. It can then find all of the new collections that have been added, go to those collections and process all of the activities in them to get to the manifests and so forth. So thus the complete ecosystem looks like this. The crawler via the registry finds the collections of activities that the IIIF content publishers produce. From there, it can index either the manifests or preferably the metadata in order to build search indexes, provide a search user interface to users, and then use the content state API to communicate the location and information about the manifest to the viewer of choice of the user, such that they can then interact with that manifest. Problem solved. So, is activity streams better than OA PMH for the purposes of IIIF? And we spent a lot of time discussing this in the Discovery technical specification group. We also spent a lot of time discussing resource sync as another alternative to OAI PMH. And we thought that activity streams is better than PMH and better than resource sync for the following reasons. So first of all, it's based on the static publication of JSON documents. And that gives us a lot of advantages over PMH. So first of all, it's just like the other IIIF APIs, in particular the presentation API, which is what it's sort of most closely aligned with. So you can write, even in a text editor, the JSON that's needed to implement this, put it in a file system, run your Apache web server, and that's it. You know, there's no database, there's no dynamic interactions or anything like that. It's just like all the other IIIF APIs. It's a modern format. You know, OAI PMH is now would have graduated university. It's 21 years old. So it uses XML. It's good for its time, but its time, we would say, has passed. So by using JSON, the developers are happier because they're using modern formats, and thus they can use modern tools, which have better support, and both in languages and in institutions. The activities can reference data in any format. So one of the perhaps advantages of PMH is that you have the get record operation, or get records, list records, where you can get the entire record if it's in XML. The activities do not embed the manifest, they simply refer to them, and thus they can reference data in any format, be that a binary image, a JSON manifest, or a MARC metadata record. We don't need a database to implement activity streams, which is then much more sustainable. So if there is a database, great, but you don't need it because it's just static JSON that's published and updated whenever the system updates its records. So there's no compute needed at the end of the web server, meaning it can be, and indeed has been, implemented simply by putting the JSON into GitHub pages or any other content distribution site. It's very easy to cache, which improves performance. So one of the issues, of course, with the use of database, you need a database server, and you are limited in performance to the scale of that system. Because it's static, web servers will simply cache it as much as possible to allow the limited resources to be used by more interesting tasks. It's a W3C standard, comes from the Social Web Working Group, and it's linked to open data. So this is good for the ecosystem generally of data on the web, rather than PMH, which is pre-linked data, before Fielding wrote about REST even. It's a service-oriented architecture rather than a resource-oriented architecture. And in terms of IIIF, not necessarily everywhere, but certainly for IIIF, it moves the complexity from many publishers in the IIIF space to fewer clients. So instead of the publishers all having to bear the burden of implementing a database and et cetera, instead the client has a little bit more work to do, but the client has the motivation to do the work because it's the one retrieving the valuable content from the publishers. So we think that it balances out that complexity more effectively than PMH does. But there's some downsides, of course. Not having a database means that sets, OAI sets, need to be materialized out as separate activity streams. So if you have a set of photographs and a set of books, you can't just have the database manage the records in a single stream and partition them up into those two sets. You would need to have two separate activity streams, one for books, one for photographs. But this isn't really needed for the IIIF use cases so far, because the majority of the use cases is just give me everything and I will sort it out via the metadata rather than at the activity stream level. And secondly, storage is cheap. You can materialize huge numbers of activities because each of them, as we'll see with Jeff's presentation, is only small. You can't query for the sort of changed since or last updated time. Start from this point and move forwards is one of the common features of OAI PMH. So this is some of the movement of complexity from the publisher to the client, and the lack of database. So we think that this is actually okay because the requirement is that the activities are published in reverse chronological order. So the most recent one is at the end of the list. So instead of working from when you last saw it, you then start from the end and work backwards up until the time when you've seen the activity. So instead of having give me all of the records changed since time X, you'd start at the end and you would work backwards until you hit time X, and then you know that you've seen them. So it's still pretty easy to use, and it reduces the cost overall. So from a IIIF perspective, activity streams is better for our use cases than PMH. So thank you for your attention to my section. If there are any questions or thoughts, comments, I would be very happy to hear them. Should we move on to Jeff then?
Sorry, I have a question for you, Rob.
Okay.
In the Change Discovery API, is there a way to reference a CAlso link directly within the activity streams?
Yes. Yep.
Yes.
So the reference to the manifest can have two bits of information. Well, it can have any information that's important, but the ones that the TSG considers as particularly important The C also link to the metadata so that you don't have to retrieve the manifest at all. You can just grab the metadata. And the provider, so that you can see who the provider, the IIIF provider of the content is, again, without having to dereference the manifest. That lets you then index the content against the providers and give them the appropriate credit that they are due.
Okay, great. Thank you.
Thank you. Oh, if there's no more questions, maybe we'll go on to Jeff.
Great. Can folks hear me all right?
Yep.
All right. I'm going to apologize ahead of time. I'm actually on holiday right now. So if you hear a child yelling in the background, it's just my son asking me to come out and play at the beach with him. So just a forewarning. So are folks able to see my presentation all right?
Yeah.
And there's no other sort of Zoom stuff blocking the view?
No, just your presentation.
Great, thank you. So my name is Jeff Mixter. I'm a software engineer. I work at OCLC Research. I've been involved with the IIIF Change Discovery working group for about 2 years now. And one of the things that I was that I said I would do a few years ago was start building a prototype just to sort of test some of the mechanics and features and functionalities that Rob went over with some data that we have Content DM via our, at OCLC, excuse me, via our Content DM partners. So today I'm going to go over sort of the technical, sort of the nitty gritty, the JSON curly braces type of structure that you can expect to see if you build or specifically harvest Change Discovery API. But also, as Rob did, I'm sort of going to break it down sort of abstractly before we just jump right into the sort of gnarly JSON data. And again, as Rob mentioned, if there are any questions, please feel free just to interrupt. We don't need to wait to the end, especially if it's about the JSON data. So at a very, very high level, and Rob already went over this, so I'll try to make this brief. There's a structure to these to this change discovery data, which is based on, as Rob said, the W3C activity streams ontology specification. So sort of at the very highest level, you have this ordered collection, which in essence is a parent page for structuring and organizing pages of activities. At the next layer down, you have these ordered collection pages, which, as the name implies, are pages of activities that themselves are then sort of nested within this ordered collection. Then going down one further layer, you have an activity, which is an individual activity that correlates to a change to a resource. So this could be the photo was modified or the metadata associated with the photo is modified, whatever generates a change with regards to your IIIF resource, that would be encapsulated in an activity. And then finally, there's this object called an object, which, as Rob mentioned at the very end, is sort of cached information about the thing that was acted upon. So this could be, if it was a manifest, for example, it could be in this object, you could have a link out to the metadata for it. So basically it's to help ease the burden of a change discovery crawler by providing useful links directly in the activity stream, as opposed to requiring the crawler to go off to follow the manifest link to then find all these other bits of information that it might need to do indexing. And I have examples of all these, so hopefully it'll become more clear as we start looking at the actual data. So this is the basic structure. As Rob mentioned, the top layer, that ordered collection thing, that's basically a set. So you can build your ordered collection. It could be anything you want. So if your digital collections is broken into 100 sub collections, you could have a ordered collection per sub collection. You could have an ordered collection per genre if you have manuscripts and maps sort of spread across all of your collections. It's really up to the data creator or the activity stream or change discovery supporter producer to decide what resides at this ordered collection. So just sort of get a little bit more concrete about how this would sort of look in the data. Here's just sort of a high level structural example of what you would expect to see. So if you have an ordered collection, and let's just call it order collection 1, and then you have page 1 and page 2. So this would imply that there are 2 pages of activities associated with this ordered collection. And then once you've gotten into the ordered collection page 1, you can have individual activities. So here you can see that this entire ordered collection has 6 activities that have been sort of partitioned across 2 ordered collection pages. And the breakdown of these is really up to the data provider. So the specification does not say, each page must have X number of activities or can only have X number of activities. So it's really up to the data provider to figure out what makes the most sense in terms of the crawlers that are going to be consuming this data. So this is sort of the structural example of what a change discovery API response will look like. Jumping into the data example, again, I apologize, this is going to be JSON, but I tried to make it as large as possible, and it's also annotated so we can sort of walk through it together. So this is the JSON that a client would see for an ordered collection. So starting here, so just at the top and working our way down, this ID block, this is the URI for the change discovery stream. So this is where a crawler would initially go to begin harvesting this particular ordered collection. This type field is basically a classification into what is this thing, and this is declaring that this document, this JSON document that you found or retrieved, is this top level ordered collection type of document. This number indicates the total number of activities associated with the stream. So we can see here there's a total of 399 activities that have happened within this particular ordered collection. Jumping down to the see also, Rob mentioned this earlier. This is basically a link out to information about the provider of the stream. So this could be a data set description, sort of describing what you'd find in this ordered collection, along with who is publishing it, who's supporting it, et cetera, et cetera. And then moving further down, we have a link to basically the first page within this ordered collection. And then finally, we have the last page for this specific ordered collection. So you can see here, the first one is page 1, so we would assume. The last one is page 8. So this would indicate that there's 8 pages of activities within this ordered collection. And then going back up to the further up the top here, with across those 8 pages, the crawler can expect to find 399 activities within it. So as Rob mentioned, what a crawler would want to do is go to the last page first and then work its way back. I did not do that for this example, so I just went to the first page just to sort of show you again the basic structure. So this is now for page 1 within the ordered collection. So again, we can see this ID field here is the URI or the URL for this specific page. So the crawler knows where it is. If it fails, it can go back to its most recently seen ID, for example. there's a part of field which links the individual page to its parent ordered collection. So if for some reason a crawler doesn't start in an ordered collection, but rather finds itself on an individual page, it can always link back to the parent ordered collection object to either pick up where it was or figure out where it was within its crawling. There is a field called start index, which is an offset for what activity you're at. So page 1, the offset would be 0 because you're starting at the first activity. And then the next page would be whatever its next offset is. So if each page has 20 activities on it, page 2, its start index value would be 20. Then you have this next field, which tells the crawler what the next page in the stream is. But for the purposes of crawling, because Rob mentioned just to do a crawl, you want to start at the last page and then work your way back. There's a corresponding prev field in the JSON that points to the previous page. So if we were actually crawling this, we would have started on page 8. There would have been no next because page 8 is the last page, but instead there would have been a prev value here that would have linked you or linked the crawler back to page 7 of the stream. And then sort of this is where sort of the important stuff is in terms of a data consumer. There's a ordered items list in JSON that includes all of the activities for this specific page. So this is a list of all of the activities, and then actually I'm going to go into sort of more detail about these activities on the next slide. But this is where a crawler would actually begin to harvest the items within the stream, actually the activities within the stream. So looking at one of those activities in more detail, this is a what resource was acted upon by this activity. So this happens to be a link off to a IIIF manifest, just indicating within the activity, this is the thing that was acted upon. There's a type field, which indicates what type of activity was this. So in this case, it happens to be a create. You can also have update and delete activities. There is a end time, which indicates when did this activity happen to occur. And then also, this is an optional value field. There's an actor field, which basically is used to describe who initiated this activity, what organization or what individual actually caused this change to occur to this specific manifest. So again, this is where a crawler is going to be really interested in terms of being able to harvest and index the data that it's working with. And then finally, the previous examples had been data from the stream that I had built for prototyping, but my data is actually, or my API is not up to date with the most recent form of the API. So I took an example from the website to show in more detail what an object within an activity can look like. And this is actually directly related to Reggie's question to Rob earlier. When a crawler is harvesting these activities, it likely doesn't care. Well, it does care about the manifest, the thing, the IIIF thing that represents the digital objects. But for indexing, it really is going to probably care mostly about the metadata for that thing. So it can either update the metadata or create a new record in a database based on something having been created. So within the object that's nested within an activity, you can use this see also, which links you out to the metadata associated with this manifest. So as opposed to the crawler having to go to this manifest and then find the metadata, it can just get it directly from the activity stream. So basically this object JSON block can be seen as cached information associated with the manifest that helps ease the burden of the crawler from having to go off and resolve a whole bunch of different URLs just to get to what it really probably cares most about, which is the metadata associated with the with the item, with the object here, the manifest. So I'm going to quickly go over this because Rob did a very nice job of this already. So that was the sort of the structure of an activity stream at a sort of basic level. There's processing logic associated with that as well. And that processing logic is basically crawl the ordered collection, follow the last link to the last ordered collection page, harvest all of the activities for that ordered collection page in reverse order, and then follow the previous link and basically repeat steps 3 and 4, or sorry, bullets 3 and 4, until there is a timestamp associated with an activity which matches the last time the crawler had hit the change discovery endpoint. And once you've done that, you're guaranteed to have picked up any changes since that date in time. So I know we're running short on time, so these slides will be shared. So I'm not going to go through sort of a live demo example of this, but this is a link off to a ordered collection. I guess I can show that briefly. This is a live service. It's an experimental service, mind you. So its reliability would be, it's not a production service. But that link in the slide, the last slide there, will take you off to this service, which is a change discovery API for a specific collection within Content DM. So I think it was the one we were working with. So if you go back to its order collection page, you will see that there are those 399 activities. And then the processing logic would be go to the last page, process all of these activities in reverse order, and then continue on to the previous page, which is page 7, do the same thing again until the timestamp in this end time field matches the timestamp of the crawler's most recent crawling of the service. So I will stop there, and if there field any questions, if there are any, otherwise turn it back to Glenn and Régis.
Any quick questions? No, should we go to Régis? If you do have any questions, then feel free to ask them in the chat. Régis, are you're good to go? Ah, great.
Okay, can you hear me well?
Yep, we can hear you now, thanks.
Okay. So I'm Régis Robineau. I'm the technical coordinator of the Biblissima project in Paris. And thanks for having me and letting me present this IIIF Collections search engine. So this is the homepage, and just a few words in a nutshell to present what it is. So it's a search and discovery environment for IIIF compatible manuscripts and rare books, but only dated before 1800. It is online since December 2018, and it has been significantly enriched ever since. But for the moment, we are still considering it as a prototype, most importantly, as a complement to the main Biblissima portal, which is available at this address in English. And so this portal aggregates a large amount of specialized data on manuscripts and early printed books, with data mostly provided by the Biblissima partners and dealing with many different aspects of manuscripts and incunabulous, whether digitized or not. So the differences between the two is that the IIIF Collections platform only aggregates IIIF manifests, so only digitized materials compatible with IIIF standards. And so it does not offer the same level of interlinking and does not go as deep as the Biblissima portal in terms of metadata processing and reconciliation. But as of today, this prototype, this website, lets you search across 17 IIIF digital libraries in the wild, and you have the complete list on the homepage. So you have Gallica, the Bodleian, Karlsruhe, Codices, etc. Stanford, Parker Library, and other digital libraries from the IIIF community, which represents about 75,000 digitized objects indexed and referenced within this website. So I can show you a very quick tour, but we are running out of time, so I will be quick. So there is a main search bar at the top where you can use free search, free text search, or you can also use advanced search parameters to get more precise results by using quotation mark, wildcards, fuzziness, must or must not operators, etc. You can perform an empty search to get all the results and then filter them by digital collection on the left, or by library, by places of origin and publication of the books, by language, or by date. So you can search for a manuscript shelf mark, for instance. It's almost always the first result that is relevant. Or you can search for a name like Fleury and here you get all the results, both related in some way to Fleury, both the abbot of Fleury or the abbey of Fleury in central France. So you can then narrow the results to manuscripts from the abbey of Fleury, from the location, by using the location facet here, for instance. Yes, and then you get 11 results. And let's pick the first one from the BNF. And here you have the metadata from the manifest and from the source metadata record. And most importantly, you have so the basic description of the object and all the agents, the list of agents related to this manuscript. So the author, the translator, the former owners, etc. So here you have the author Titus Livius. So I can click on this link to have more information about this author and his works on the Biblissima portal if I'm interested in. Or I can also follow this link to the Biblissima authority file, the Biblissima authority record for this person. And here you have a very basic description, almost only the dates in this case, and identifiers and links to other authority data on the web, like the BNF the Library of Congress, the GND, the Search Thesaurus here, or Wikidata. And you also have a property, let's put this in English, maybe. You also have a property to called search results in IIIF collection that you can click to get a list of all the books related to this particular entity, so to Titus Livius in this case. So this platform is where we manage and share all the results of the reconciliation and alignment process that we make on the different entities we are harvesting for the IIIF collection platform and for the Biblissima portal as well. So let me try to answer a few questions on how this prototype works behind the scene. So first, how do we harvest this data? So we are mostly relying on OAI PMH endpoints and IIIF collections URLs. So one example of IIIF endpoint is Karlsruhe in Germany, for instance, which provides a MODS metadata format for each record. But of course, usually we can get no more than simple Dublin core from this source. But whatever the metadata format, one of the problems is that most of the time the manifest URL is not present within the source record. So we have to guess how the manifest URL is built and try to identify which ID is used to build that URL. Because, for instance, in this MODS record, there is no manifest URL. And when we harvest the metadata, we have to guess how the manifest URL is actually built. So, of course, it's easier when we can harvest IIIF collections directly. And this is the case for the Bodleian library, for instance, or for eCodices, the virtual library of manuscripts in Switzerland, or the Parker Library in Cambridge, and for Durham as well. In these cases, we are harvesting IIIF collection like this. So this method is quite convenient. It's a quite convenient way of harvesting IIIF resources, but I should say it's not ideal either. Indeed, the IIIF collections were not specifically designed for this purpose of harvesting and crawling IIIF resources. And there are several ways of implementing them. IIIF collections can be nested on several levels. Sometimes they are paginated, but not always. One manifest can be referenced in several sub-collections, etc. And most importantly, what about the metadata, of course, as Jeff underlines? Because obviously this is what we're interested in while building a search engine like this. We have to have a list of IIIF resources, but also to have the metadata related to these objects. So then when we have a list of IIIF manifests, the question are, do the manifests include metadata? If yes, is it complete compared to what is present in the source metadata record, if accessible, or compared to what we can see on the library website? And I can say it is often different or incomplete. There are pieces of data that are present in the source metadata record or on the library website that are not present in the IIIF manifest. And last but not least, do the manifest point to a structured metadata file via the CALSO property? So that's the kind of question that are raised while working on this prototype and harvesting those IIIF resources, which leads me to the next question, the second question, which is how do we process and index the metadata? So it won't be a scoop to say that this landscape is very heterogeneous and is by far the biggest hurdle to build a search engine like that. Of course, we have to deal with a wide variety of metadata standards. It could be mods or METS mods, it could be double encore, it could be TEI, it can be EAD, or sometimes the only thing we can get is the key value pairs from the metadata block of the IIIF manifest. So as Rob said, metadata that is only made for presentation and that is not standardized, so it's not an ideal situation. So I can quickly explain what we are doing on this front before ingesting the data into the system. So first, we extract a descriptive metadata field from whatever we have at our disposal. So as I said, it could be from a machine readable resource linked from the manifest via the CRSO property, or directly from the OAI record, it depends, or from the manifest itself as a fallback if it's the only thing we have. Next, we try to filter the list of objects by date when available by evacuating all the materials explicitly dated after 1800. Then we normalized the dates formats and convert them to a date range that can be leveraged in the facet I showed you before in the web interface. We also normalize the strings of languages for the same purpose. And the final step, which is the most important one, we are trying to reconcile and cluster entities like places and agents, like all the authors, translators, copyists, former owners, etc. And this process, as you probably saw, is based on the Biblissima authority file, which already contains a large amount of preferred and alternate name and URIs to linked open datasets like VIAF, the BNF, the GND, Wikidata, the Library of Congress, or geonames for places, etc. And all the reconciled entities are then feeding our wiki-based platform I showed you before, where we store and share all the authority data in Biblissima. That is to say, all the shelf marks of manuscripts and early printed books, all the agents, all the places, and other entities like iconographic descriptors, etc., etc. So just to finish, a few comments with respect to the harvesting part of the job. Of course, relying on a IIIF Change Discovery endpoints, as Rob and Jeff showed us, would be a tremendous step forward to build such a search engine. It would provide a consistent and more efficient way of crawling a list of IIIF resources. It would also make updates a lot easier, since we could easily know which resources have been changed or added since the last crawl, which is something that we are not able to do right now. It would be even more efficient if as activity streams themselves, or at least the individual manifest, could always reference a CRSO property with rich structured metadata that we could retrieve and process. And it's quite, it's not always the case within the IIIF community. And it would be an even more ideal situation if the entities within the source metadata had been already aligned and identified by web URIs. And finally, let's imagine a central IIIF registry of activity streams endpoints to harvest from, I think we would have, it would be a dream for IIIF Aggregator to be able to rely on this.